So hi all, today I am going to take an online class on Laplace Transform. Okay, earlier we learned about the Fourier Transform equation, right? So the expression, let me write the expression for Fourier Transform, that is x of jo. This is the equation for Fourier Transform is equal to f of x of t. We also write like this, which is also equal to integral minus infinity to plus infinity x of t into e raised to minus j ohm t dt. This is the equation for Fourier Transform. Okay, so now when I want to write the equation for Laplace Transform, I write it like this. We can write it as x of s, or it is also called as capital letter L of x of t is equal to integral minus infinity to plus infinity x of t into e raised to minus st dt. So the equation is very simple to remember. Look at the Fourier Transform equation and the Laplace Transform equation. The only difference is the power of the exponential function. Here it is e raised to minus j ohm t, whereas here it is e raised to minus st. Okay, so what is the difference between s and j ohm? J ohm is nothing but your angular frequency. So what is s? S is the complex frequency. The complex frequency. So like all complex numbers, s has a real part and an imaginary part. So s is defined as sigma plus j ohm. This j ohm that you see here is the same j ohm that you use for the Fourier Transform. So this s consists of real part and an imaginary part. Sigma is called as the real part of s, and j ohm or simply ohm is the imaginary part of s. Yes, so this is how we define the s. So what is the main difference other than the variable? What is the difference between the Fourier Transform and the Laplace Transform? Okay, to understand that, then first you should understand what is Dirchlet's condition. Dirchlet's condition is the condition that ensures the existence of Fourier Transform. That is, if a signal wants to have a Fourier Transform, it should first satisfy the Dirchlet's condition. So one of the Dirchlet's condition for a Fourier Transform, one of the condition is that the signal must be absolutely integrable. That means integral minus infinity to plus infinity magnitude of x of t must be a finite value. That is the meaning of Dirchlet's condition. That means the signal must be absolutely integrable. So unless if it is integrable, only the Fourier Transform of that signal is defined. Otherwise we cannot define that Fourier Transform equation. Okay, so here this is what you need to understand in this case. Okay, here you can see that if you look very carefully, x of t is multiplied with e raised to j ohm t. So now if I am going to substitute the value of s is equal to sigma plus j ohm. If I substitute this value in this equation, let's see what we will get. I will get it as x of s is equal to integral minus infinity to plus infinity x of t into e raised to minus of, replacing s with sigma plus j ohm, I get sigma plus j ohm into t dt. Okay, I can also write this equation in this format, that is integral minus infinity to plus infinity x of t into e raised to minus sigma t into e raised to minus j ohm t dt. Okay, so this is the main difference between Fourier Transform and Laplace Transform. Here you can see that the x of t is multiplied with e raised to minus j ohm t, whereas here this term is multiplied with e raised to minus j ohm t, that is x of t into e raised to minus sigma t. So that means just like how I applied the Dirchlet's condition over here in the Fourier Transform, if I apply the Dirchlet's condition to the Laplace Transform, I can say that the Laplace Transform of that particular signal exists if and only if integral minus infinity to plus infinity the magnitude of x of t into e raised to minus sigma t becomes a finite value. So you see, that's the difference. This is the Dirchlet's condition of Fourier transform, but this is the Dirchlet's condition of Laplace transform. If you see the difference between these two conditions, this term is the difference. That is e raised to minus sigma t. Okay, so that is the main advantage of Laplace transform over Fourier transform. In the case of Fourier transform, the existence of Fourier transform depends on this equation, which in turn depends on x of t. Whereas the existence of Laplace transform depends on this equation, and this equation depends on two things. That is, one is our signal x of t, and the other is the value of sigma. That is one of the main advantage of Laplace transform. That means in the case of Fourier transform, if the signal cannot be integrated, then you cannot find its Fourier transform. Whereas here in this case, if the signal cannot be integrated, if the signal x of t cannot be integrated, then we can define the value of sigma such that this equation can be integrated. So that means the Laplace transform exists for some signals, whereas the Fourier transform is not exist for that very same signal. So you see, so that is the difference between Laplace transform and Fourier transform. That is, we can find the Fourier transform of some signals, but we cannot find the Fourier transform of some other signals. But in the case of Laplace transform, depending on the value of sigma, I can find the Laplace transform of all the signals. That's the main difference between Laplace transform and Fourier transform. It is all because of this term over here, sigma, the real part of S. This is one of the main advantage of Laplace transform S and the Fourier transform JO. Okay, so this sigma, or the real part of S, as we call it, is also called as the convergence factor. That means it is the factor in which the Laplace transform becomes a value, or it reduces to a value, or it converges to a value. That is why sigma is also called as the convergence factor. Okay, so this is the basic introduction of Laplace transform. Okay, so now before we move on, let's do a simple problem about convergence factor. Okay, so before we continue further, I want to give you a small briefing about the ROC. Okay, ROC is nothing but, it is also called as the region of convergence. Region of convergence. Okay, so region of convergence, that is it is the range of sigma over which the Laplace transform exists, or it is the range or the values of sigma over which the Laplace transform converges to a single value. That value is called as sigma. Okay, so this is my introduction to Laplace transform.